All right, so I saw everybody had the right derivative or velocity, had the right graph, and just know that the original one gives the position that the ladybug is from the base of the trunk, right? So, and the ladybug is moving like back and forth on that branch. Okay, so if we do have a negative velocity right here, so what does that mean about the direction the ladybug is walking? Right, closer to the trunk or toward the trunk. The distance is getting smaller. Right, positive away. Okay, and then what time is Ladybug at rest?
3 minutes.
How do you know?
Because the slope of the graph is 0.
Good. So the slope of this graph is 0 at that point, or the velocity is 0. Good. Okay, we want to find v of 1. Did you guys find v of 1?
Yes.
What did you get? All right,
Yards
what?
per minute.
Yeah. So that means at that minute, the ladybug is going towards the trunk. All right, and then v prime of 1. What about v prime of x? What is that? Acceleration. And what is it equal to? Just 2. It is also equal to s double prime. And so that means the acceleration is 2. All right, let us interpret this. So if we're doing v prime of 1, what is changing? Right, rate of change or velocity? Would you say increasing or decreasing? We're going to say is. By 2 yards per, what do you guys think?
Minute.
Yes. At t equals 1 minute. So don't forget your net. Noun, unit, and time. Okay, this is the big question. The velocity at time 1 minute is -4. The acceleration is +2. So what do you guys think? Is the ladybug speeding up or slowing down? Yes. And the reason is the acceleration and velocity are working against each other. The ladybug is pushing this way. The acceleration is pushing this way. So the acceleration is slowing it down. I know that seems confusing because everyone always thinks a positive acceleration means speeding up. That is not what it means. The velocity is increasing. The speed doesn't take into account that positive, negative. So the reason is the ladybug is slowing down is because the velocity and acceleration are working against each other. All right, and we'll get a little bit more better wording with that on your note sheet.
It's just like the same as like whatever you have like on number,
Mhm.
right? Where it's just like it's decreasing, but the slope is increasing, right?
I don't know if that can go into the same concept. The way I think about it is like think about wind resistance. So you're in an airplane and you're flying one direction, but the wind is blowing in the opposite direction, it's going to slow you down. If you're going in the same direction as the wind, it's going to speed you up. That's what I always go back to. So you're saying a minimum?
Like how, I mean, like whenever it goes like that, it's the actual thing is decreasing,
Right.
but the slope is increasing because
Ah, I see what you're saying. That yes, that is the way you can think of it. So the velocity being negative, and it is increasing, but as a negative increases, the absolute value is decreasing. Yes, that's a really good way to think about it. All right, let me give you guys your note sheet real quick. Oh, I forgot to count tools in this. Sorry.
Would it be fair to say, I don't know if this is right, but like the signs have something to do with it, like because the velocity is positive
Yes.
and or one is positive and one is negative.
Yes. That is exactly how you word it when you give a justification on the AP test. You would say the velocity and acceleration have different signs. And so the object or whatever is slowing down. When the velocity and acceleration have the same sign, the object is speeding up. Nice job. You guys are so smart. Okay, so let's fill in these notes for straight line motion. Do you guys talk about that in physics? Acceleration and velocity working against each other or together?
yes.
Okay.
And it's been 3 years, but I think
That's
so.
okay. All right.
I know we did a lot of trig and maybe not the happiest.
Aw.
You can
All
always
right.
double check.
Okay, so let's talk about the notation used for position. Now, you would think they would use P for position, right? So those physics people, what is P in physics? Sorry, I put you on the pressure. P stands for pressure in
Yeah.
physics. S usually stands for position. I honestly don't know why they chose that S. A lot of times in calculus, the object is moving on the x-axis or the y-axis. I can almost guarantee there'll be a free response question about a particle either moving on the x or the y-axis. So in that case, they call it x of t when it's moving on the x-axis and y of t when it's moving on the y-axis.
I want to say we always saw it as x of t.
Okay. Okay. All right, and then velocity usually is v of t, and you guys have figured out that the velocity is the derivative of position. And velocity is directed speed. All right, acceleration is a of t or v prime of t or which prime of s? Double prime. And the acceleration gives the rate at which the velocity is changing. All right, and then the speed is going to be the absolute value of the velocity. Speed has no direction. All right, and you guys already figured out pretty much everything in the second box, or third too. So if the velocity equals to 0, what does it mean about the object? At rest. Okay, and then just depending on the situation, if the particle or object is moving on the x-axis, a positive velocity means which direction on the x-axis? Right? If it's on the y-axis, it's going to be up. And then a negative velocity on the x-axis is left. And then y-axis is going to be down. Okay, and then this is so common, such a common question on the AP test, that when the velocity and acceleration have the same sign, they're working together, the object is speeding up. When the velocity and acceleration have opposite signs, they're working against each other, and the object is slowing down. Okay, so let's do some of these examples. I think we have time to get them all done. On the examples, I have all polynomials. On your assignment, I did throw in a logarithmic one, and I gave you some hints on it, and just in case you get stuck. I don't want you to get stuck. But the polynomial ones are pretty easy to do. So we have a particle moving on the y-axis only between time 0 and 5. And we have the position function. And so we want to know if the particle is moving up, down, or neither at t equals 4. So what do we need to make that decision? Velocity. And so y prime of t is going to be the velocity of t. And so we'll just do that real quick. And then we're going to plug in 4. Now, most of these questions are non-calculator, so it can get kind of tedious. If it ends up getting really tedious, a lot of the times, unless they say find the velocity at t equals 4, you just have to figure out if it's positive or negative. But in this case, we can do it pretty quick. That's just going to be 5. So what do you guys think? Yes. Okay. And then B asks for the acceleration at 4. So I'm just writing all the notation. All right, so we get 2t minus 2. So the acceleration is going to be 6. Now, most of the time, I think I did make up one on your assignment that I gave some units to the particle moving on the axis. But most of the time there aren't units, so you just kind of leave it like 6. Okay, and then C asks, at what time is the particle at rest? All right, so what do we need to do, and what do we need to use? Velocity, the first derivative, equal to 0. I'm writing probably more than you have to, but just I want to give you guys some reminders. Alright, don't forget about your interval on these questions. So most of the time there's only a certain time period. A negative time doesn't usually make sense. So there's only going to be one of these answers for the particles at rest. And then on D, we want to find, on that time interval from 0 to 5, we want all the values of t where the speed of the particle is increasing. So what we're going to do, move down just a little bit, is do a sign chart. So we're going to start at 0, and we're going to go all the way to 5. Oh, I drew my line a little too long. And what we are going to need to determine when the the speed is increasing, we need to know if the velocity at all those times is positive, and when the acceleration at all those times is positive and negative, and 0. Okay, so do we already know when the velocity is 0? 3. So what I would do is above 3, I would just put a little 0 on my velocity side. And then we can find when the acceleration is 0 real quick. We can just take the acceleration, we can do that in our head. So if this is the acceleration, what value of t is going to make it 0? 1. Right, and then those 2 times are the only times that is going to change direction. It's going to change sign. And so if I want to find out when, like, what the sign is for all of these, I don't have to plug them all in. I just have to plug one of them in on that side of 3. What's the easiest number to plug in the world? 0. So if I take my velocity equation and I make the t's 0, am I getting positive or negative? Negative. So that means all of these are negative. Right, and then I've already plugged 4 in. This is nice. All right, I plugged 4 in on part A and I got a positive, right? So that means all of these are positive. Okay, and then acceleration, if I put 0 in, I'm going to get a negative. And I have already plugged 4 in, right? And I got a positive. All right, what am I looking for? For the speed to be increasing.
The signs are the same.
Yes. And so I like to use a highlighter. You guys cannot use a highlighter on the AP test. But I'm going to highlight all of these areas where the signs are the same.
Wait, how did we get the A or T? Where did that come from?
That we got it up here
Oh, okay.
on B. Okay. So we have to be careful with our including or not including on these because I think they're kind of picky on the AP test. So at 0, are the signs the same at 0? Yes. So I'll go ahead and write my sentence. So the speed is increasing. That's a D and not a G. So we are going to include 0 to t. All right. Are the signs the same at 1? No. Because 0 doesn't have a sign. So we're actually not going to include 1. Does that make sense?
Yeah.
Okay. Because 0 and negative don't have the same sign, because 0 doesn't have a sign. And 3, are we going to include it? The 3? No. Are we going to include the 5?
Yeah.
Yes. Because, and the reason is the velocity and acceleration have the same sign.
Oh, wait, I see. So we plug the intervals, like one of the intervals into the t squared minus 2t.
Mhm.
Okay, that's where I messed up.
Now, the reason I went kind of fast is because, well, I plugged in 0, which makes it easy because they
Yes,
just,
that's just
and then we had already plugged in 4. So that kind of saved us some time. And the signs of the velocity and acceleration are only going to change as you go past 0. They can't change. Like if there is not a 0 here, there's no way they're going to change. It'll stay the same. Okay, let's do another one. I think the directions are is asking a little bit different, asking the same things kind of in a little bit different way. All right, for 2, we want to know that this question is the same, the direction. So and this particle is moving along the x-axis, so direction is either going to be left or right on this one. And so we'll do find the velocity by finding the derivative. And then we'll plug in 3. All right, this one is not super easy, so that's going to be 27. And then 3 times 24 is 72. Now, technically, on the AP test, you really just have to know if that's positive or negative, so you might be able to do that faster than actually doing all the addition. But anyway, you get -9 for the velocity at 3. So what does that mean about the direction? Yes. And I'm going to try to save some time. I'm just going to say left. It would be better to write out the pretty sentence, but that's okay. Okay, and then at 1, we need to know if the particle is speeding up or slowing down at 1. And so I need 2 things. I need v of 1, and I need a of 1. Right. Plugging in 1 is also pretty easy. You just have to add the coefficients. So v of 1 is going to be 15. Now, to find a of 1, we need to find a of t real quick by finding the derivative of the velocity. Right, and then again, I can just add the coefficients. What do y'all think? Speeding up or slowing down? Slowing down. Now this one did not ask us to justify. They almost always do. The reason is because the velocity and acceleration have opposite signs. Let's go ahead and write that. Okay, and then C is a question that you kind of see a lot also, and it's easy to get wrong. And so C asks us if the particle is moving toward the origin or away from the origin at t equals 3. Now we've already found the velocity at 3. So we found it earlier in the problem that v of t is -9. Is that enough information to know if we're going towards the origin or away from the origin? It isn't. We have to know where it is at that time. So what function do I use to find where the point is, or the particle is, at time t equals 3? Yeah, the position function. So I'm going to cube 3. I'm going to square 3 and multiply it by 12. And then I'm going to multiply 3 by 36. Obviously, I've already done this. I don't do that math that fast in my head. You guys might, I don't know. But we're going to end up getting 27. Okay, so if we're talking about the x-axis, we're going to say 27 is right here. That's where the particle is. If the velocity is -9, we're going towards the left. So what do you guys think? Toward the origin. All right, and then on this last example, I kind of love these problems actually. So we have a particle is moving on the x-axis again, but the graph is the particle's velocity. Pay attention, this is the velocity, this is not the particle, this is the velocity. So A asks at what times is the particle at rest?
Equals 1, 2, 3, 4.
Any other time?
0.
Yes. Okay. How many times does the particle change direction? 3. So when the velocity changes sign, it changes direction.
Why does it not change up 4?
Because it is going, so it's positive, so it's going to the right. It stops and starts going to the right again. All right, and then at t equals 0.75, is the particle speeding up or slowing down? So we need two things. We don't actually have to find the values of these two things. We just need to know if they're positive or negative. So this is the graph of the velocity. We'll say 0.75 is about right here. All right, so would you say the velocity is positive or negative? What about the acceleration? It is positive. Why?
It's increasing.
It's the slope.
Yeah.
It is the slope of this graph right here. This is a positive slope.
So with v being negative, does that have to do with it being below the x-axis?
Yes. All right, so that's a positive there. So what do y'all think? Yes. All right, what questions do you guys have?